Good afternoon. My name is Liam Kiernan, and this is Chemistry, a Year in Review. So these are some of the topics covered this year's in the concept sections, and then I will go over some of the real-world applications of the things we learned in this chemistry class. So, how to separate matter was a topic that we covered this year, and in chemistry class, we learned different ways to separate all types of matter, each with different techniques. We learned how to separate solids, gases, and liquids, and how purification can impact a substance. We could separate solids from liquids with evaporation, or use the other phase changes that we went over to separate different classifications of matter. We were able to start with easier methods such as magnetism or decanting and move on to the more difficult ways to purify. Um, I got this all from my notes, and we were we were able to separate various substances in the labs that we went over. So my question was, how would one separate two immiscible liquids? And the immiscible liquids are the liquids that we're not able to mix. And the way that we were able to do that were the separatory funnels, and we separated substances such as oil and water. So we also went over the discovery of the history of an atom, or the history of the discovery of an atom, rather. And we learned how scientists arrived at how we are able to understand what the atom is today, what the atom is today. And it started with Democritus in ancient Greece, who believed in the indivisible atomos, which um, contrasted the view of the time. And the journey continued with Dalton, who theorized the basic ideal and laws of an atom, and he had the theory of the atom, which some of it came to be disproven, but a lot of it we still use today. It was a huge step to where J.J. Thomson discovered the electron, Rutherford discovered the nucleus, and Chadwick discovered the neutron. And they all, of course, came with different models that we we went over in class. That, of course, came to all be disproven, but still important to the history. Finally, Millikan, with the oil drop experiment, was involved in determining the charge to mass ratio, which is now extremely important for measurements using atoms. And so the question was, what did Rutherford use to discover the nucleus? And he discovered the nucleus by shooting alpha particles at the atoms in the gold foil experiment. And there, at the right, is the man, Ernest Rutherford. We also learned about electron configuration and diagrams used. We learned how electrons are arranged in an atom, depending on where it is on the periodic table, and how one represents that. We learned about each of the orbitals and the traits of each one, and how to represent that in the noble gas quicker configuration, or the SPDF configuration. We did this doing the periodic table almost technique, where we started with S and then the P and the D and the F to figure out each each configuration based on where it was on the periodic table, and we learned the shapes of the orbitals and the rules of how electrons configure. And my question was, what is the noble gas electron configuration of sulfur? And it would be neon 3s2 3p4. We also learned the history of the periodic table. We learned about how the periodic table was discovered and how it is best used to a student's advantage. We learned that the original table of elements implemented by John Newlands, using the idea of arranging the elements in 8 groups with repeating similar properties. Uh, this came not to be generally accepted and led to the development of a table based on the order of atomic masses by Mendeleev. Mendeleev, of course, being the most important scientist, chemists in the history, as he filled in various spots of the periodic table and was able to describe a efficient way to arrange them. And it led to what we have today in the number of protons and it's finalized by a periodic law that shows that when elements are represented in order of atomic number, their characteristics tend to repeat in a line, which is a an anomaly that we see in our periodic table, and in how the periods in the groups allow them to show similar chemical and physical characteristics. And what was Newland's law about elemental arrangement called? And it was the law of octaves based on the arrangement of eights. Ionic bonding was something we learned this year. We learned how the elements with opposite charged particles uh, were able to bond and how we named them. We learned how to determine charges from the periodic table and the properties of those bonds using Coulomb's law. We learned how the elements bond with ones on the other sides of the table. So the elements on the far right, like no gases, were able to bond with the alkali and alkaline earth metals on the far left. And we learned the names of the polyatomic ions and how to use them to bond, and how to write the chemical formulas for the bonds. And we converted all those formulas to names. And the question would be, what is CuMnO4 4? And that would be copper 4 permanganate, and it's a good metallic bonding example. And there on the right, you can see the demonstration of an ionic bond. Covalent bonding, a different type of bond, is molecular bond of sharing electrons. We learned how to use the VSEPR chart to analyze a covalent bond, and the chart allows us to understand the bond angle shapes and hybridization of each bond. And though it looked complicated at first, it allowed us to simply view how the molecules would take shape and take place after the covalent bonding. And we also explored how to name the compounds and explore topics such as molecular polarity. And one of the question is, what is the shape and bonding of a compound with any shape like it, or specifically SF6? And it's an octahedral shape with a 90-degree bond angle, and you could have seen that through the VSEPR chart. So finally, for the concepts we learned about gas laws, it was one of the last things we learned about in chemistry this year. And we learned how to determine different measurements using the PV equals nRT equation. And we were able to determine how the different variables and measurements relate to each other. So we found for the Boyles and Charles and Gay-Lussac's and the Avogadros and combined gas laws how all of the variables and units are either directly or indirectly unproportionally related. And we discover topics of what happens to balloons when they are in different atmospheres, or how gases change throughout the world. And the question would be, if a 7-liter balloon is inside when it is 290 degrees Kelvin, what will happen when it goes outside to the 270 degree Kelvin air? And the balloon will be about 6.5 liters. That's not an exact number, but in sig figs it would be about 6.5 liters. So a real world application from this chemistry class would be dimensional analysis. And I find this extremely useful in aspects of life, like baking, and especially for me, who's a track runner. Uh, Honestly, I use dimensional analysis, maybe not the entire carried out route, but pretty much every day. Or every track meet at the least. It's something that we learned in converting measurements from metric to, we could convert them from small metric units to US units, or from metric to metric, or US to US. Be used if you ever want to know how much of a liquid is in a gram of something, or any problem that used measurements with units. So example of this would be finding the amount of feet a 6-meter jump during a track meet, which is what a lot of people my age often tend to jump around that or larger. And that at the right is a track, of course. Separation of mixtures, especially chromatography or distillation. So chromatography, the classic example is that you use that at a crime scene to decipher the ink and the pen used to the crime. Also, distillation is used in alcohol and water in purifying the liquid so that it's safe to drink. Frequency. We also learned about frequency, which can be used to determine energies of radio stations and give you a better understanding of what the MHz megahertz means at the end of the radio station. And it also relates to the real world and being able to understand how different radio stations are translated. Like the transmissions are gotten to the car. We also learned about how the electromagnetic spectrum that helps us understand our phone signals, relates to the phone signals, and it helps us, understand concepts of 4G and why 5G is so important and how the spectrum affects that. And thank you for listening, and thank you for a great year.